Hey everybody, today we will do a quick video, and today we will do a video on digital logic. Um, okay, so it's going to be changing a fraction in base 10 to a binary equivalent in base 2, right? So basically changing a fraction on given in base 10, right? So we'll say given in base 10 to an equivalent, okay, fraction in base 2, right? So I think last time I explained that base 2 is binary, right? Or you can say binary base 2, right, to be more descriptive. Okay, to in base binary base 2. Okay, so obviously binary, we know what it is, all right? But again, this is, now I changed the name of the channel, right? I call it, now it is a Christian Engineering Academy instead of Conservative Engineering Academy, right? So again, binary, this binary for nowadays, apparently they say non-binary, right? Non-binary is the new term now for people that want to describe that you can be non-binary, which means that you cannot be male or female, right? But the issue is the God created male and female. The God created them. And again, this might not be the channel for you. It's okay. I am good with it. You like it or not. I am a Christian, and I will stick to being a Christian, and I will not change my Christian values for anything. For subscribers, I don't care. Period. Right? I am an engineer, but I am not a liberal engineer that believes in all this nonsense. Right? So, with that being said, let's get it started. All right. So non-binary. Okay, never mind. Right. So not gonna go into that stuff. Right. So 93 over 128. Right. So 93 over 128. That is the number given. Right. So we change this guy to a fraction in equivalence base 2, right? So how we do this? We divide this guy by this guy, right? Fraction base 10, right? This is a fraction in base 10. I need to change this, change it to base 2. All right. So how we do that? Okay, so first of all, I got to do 93 divided by 128, right? 93 divided by 128. So 93 divided by 128 is equal to a number that is like, okay, big number, 0.726562 right? This is okay. 726, right? 6. Okay, 65625, right? Okay, so now we time this guy by 2, right? Why we time this guy by 2? Because we're looking for this number. We're looking for base 2 multiplied by 2, right? By 2, right? So multiply this guy by 2, right? And then we take that number multiply by 2, right? So multiply this by 2, right? So that remember that we divided the decimal and we're getting a number. And right here we get a 0, right? But we don't care about this yet because we did not multiply by 2. We will care about any zeros after we multiply by 2. And I wanted to make this clear. We don't care about the 0 right now because we have not multiplied by 2 yet. Once we get this result, then we will care about the number is on the left, right? So multiply that by 2 is equal to 1.453125, right? Now we care about this. See? Now this is what I'm saying. Now we care about this, right? So now we care about this. We care about this. Now that we care about this guy, we do 1, right? That's our first number. But remember, because it was a fraction, we still have to put a 0. A 0 because what? It is a fraction, right? So it is a fraction. Still have to put a 0 in there. Now, why? Because technically that's how we write decimal, right? Decimals in binary doesn't. It's the same as decimals in base 10, but because technically a fraction is a decimal, it's just written in a different form, right? The fraction was given in decimal, but now we change it to binary. We just changing the base, right? We change it from one numbering system to another numbering system, if that makes sense. Okay, now we got a 1. That's our first one, right? We take this number and multiply by 2. We don't divide anymore by this. We take this remainder. This is the remainder, right? And multiply by 2. Now we take 453125 times 2, right? And we get 0. Multiply this guy by 2. Now we multiply this guy by 2. So actually, I don't have to put in. Well, yeah, the same thing because it's a decimal. So take 453125 times 2, and that is equal to 0.9. Okay, yeah, 0.90625, right? Now we care about this. First we care about that. Now we care about the 0. We care about the 0, so therefore we write 0. Okay. Now, what we do next? We multiply this guy again, right, by 2 because that is the next number, right? So multiply by 2 again. Multiply that by 2 again, and we got what? We got a 1. So now we got a 1. Well, we got a 1 to the right, right? But let me do this right before I get anybody confused. Just, this is easy. It just take a couple steps, right? So now we take 9.9. Remember, we took care of the 0. That's the 0, right? Now 9,062,5 times 2, and that is equal to 1.8125, right? Now we care about this one, so we write 1. Again, now, remember that we care about this. We're multiplying this now, right? So now I multiply 0.8125 times 2, and that is equal to what? Times, so we do 0.8125 times 2, and that is equal to 1.625. And now we care about this guy. We write that one, right? Write 1, right? Now, again, we care about the number to the left of the decimal, right? Now, but after we multiply the fraction, we care about the number to the left of the fraction, right? Now we actually, you know what? I think, okay, so see the 0 right here, right? Technically, we care about that, right? But what I was saying at the beginning is, you know that the decimal in binary is going to start with a 0, or with a 0 anyway, 0 point something, right? Well, if this is confusing you, what you can do is say, okay, let me put the 0 first in the answer, right? I get the first number, let me put the 0 first. To get the rest of the number, then I multiply the fraction by 2 and just keep writing the numbers. That makes more sense to you, right? Now we take 0.625 times 2, and that is equal to 0.625 times 2, and that is equal to 1.25, right? Now we care about the 1 again, right? We care about the 1. We care about this guy. Now, what is next? Next is going to be what? Next, okay, so next, let's see, real quick, I think. So next is going to be 0.25 times 2, right? That's the number that we care about, right? So then that is going to be equal to what? Oh, I will see. It's 0.5, right? So 0.5. So now we do 0.25 times 2 is going to be equal to 0.5. And that is going to be give us a 0. Right? 0, because we care about this guy. Then we go to the next, and now we care about this guy. So we do 0.5, right? 0.5. Again, we care about this guy, right? But technically, we're just multiplying this again. But again, it's kind of confusing because you still care about this now. Because, I mean, 0.5 is just the same as 0.5. It doesn't matter. In the calculator, you don't want to bother and just put 0.5. It's going to give you the same answer. It's going to be equal to 1 again. It's not going to make any difference. So you put 0.5 times 2 is equal to 1, right? We stop. After we get 1 at the end, when you see that 1, we stop. We stop right there. Then we put that 1 over there. And that is the last number that we get. Now we don't have any more decimal points to the right. We stop. And that is the answer. Okay, that's it. That's it for the problem. I hope you learned something about changing out a decimal fraction given in decimal to a binary equivalent, and that is the answer right there. That is the process, and I hope you learned something. Thank you for watching, and God bless you, and I see you in the next video.